what the organizers call the digital special. So we wanted to do a little bit of philosophy of AI, philosophy and ethics of AI. And in this panel, you have the speakers, which is Colin Allen on my left. I'll say more about him in a minute. Björn Lundgren here. And so it was supposed to be Emma Rotkamp-Blurm from South Africa, but she had family issues that prevented her from coming here, and so Björn stepped in at the last minute. So be lenient with his presentation. It is a quick job. We are essentially trying to do a couple of relatively general things about the philosophy of AI. And I will start with a small presentation on AI ethics and what I think is problematic about it. And then we will continue with two more short presentations and have a longish discussion at the end. Right, so we'll have a discussion about all the presentations at the end. Okay, so Vincent Müller, I'm working at Erlangen. I'm running a research center there, philosophy and AI research, called PAIR. I am the kind of person where people frequently say, oh, he's an ethics on AI, he's an expert on AI ethics. And I'm always feeling a little uneasy about this idea that I'm an expert on something. I wonder where the expert is somehow. It has to be somewhere around here. This is sort of the beginning of this presentation. I've been thinking, why is that I have this unease about it? I think the reason is that we're having a really, really big task on our hands, and that is something we haven't, I think, fully appreciated yet. So this is point one on that presentation, which unfortunately I can't see here. By the way, are the tech guys? Is there any way that I can see my own presentation here on the slides? Because I have to turn. That's not ideal, but yeah, okay. So the first thing which makes AI ethics difficult to handle is that it is a huge societal problem. There's gigantic societal demand, right? There's like AI ethical discussions are everywhere in the newspapers, and I don't know, on Saturday I was sitting in a cafe in Erlangen and I realized the guys next to me were talking about AI ethics problems, the way they perceived them. They were clearly not experts, but they were worried about this. So there's clearly some demand that we, the experts, should provide something, right, to society. And I think that's, first of all, something that's important to realize. That's point B there. AI ethics isn't driven in the same way as other philosophical discussions often are. We aren't driven by the traditional philosophy and traditional problems that we already know how they work and the methods people have. That's not the push that we have. The push is from that societal angle. So we think there are real problems and we need to see how to understand and to analyze them. That is different from normal philosophical work, it seems to me. Point C is not only a huge task, doing it seriously is really quite a recent affair. So I've written a little paper on the history of digital ethics or computer ethics. So the first sort of serious paper on what I would call AI ethics is by this gentleman here, I think, Colin Allen, that is on artificial moral agents. And then there was a bit of a tendency to talk about, machine ethics, robot ethics. Robot ethics was quite fashionable sort of in the, let's say, late 2000-something, 2000, 2010. And the first papers about this appeared in 2005, 6 or so. People thought at the time that robots, which are sort of the visible end of the computer technology, are an important point of ethics, and that the important question was how to build morality into that machine, right? So machine ethics. The first conference, as far as I know, was organized by Nick Bostrom and myself in 2012 on AI ethics. AI risk, actually, was the term. And the first surveys occurred in 2020. 2020, okay? That's 4 years ago. So it's not that we have a well-established discipline where everybody knows what they're doing and what the methods are and who is doing what and so on, right? It's new, okay? Just for philosophical terms, this is extremely new. So the result is point D. Lots of people say that they're experts on AI ethics, and I'm always kind of puzzled when I hear this. I often get on panels and they say, oh, here are other experts on AI ethics, and I've never heard their names, and I wonder what's going on. And what is the problem is also underdefined somewhat. So, for example, if you speak to technical people, they say, tell me what you think I should and should not do in technical terms. If you speak to politically oriented people, they often talk about regulation, right? So they think AI ethics is the field that allows regulation. So it really depends on what you're up to, what determines what you think AI ethics is. So I think in a sense the problem is pretty serious in terms of scope and method. So what is part of AI ethics and how do we do that? As far as the scope is concerned, I have a proposal. It's not good news though. The proposal is that the scope really is very broad. So people think of AI ethics as applied ethics. And they sort of think, okay, what is applied ethics? It's the kind of thing like medical ethics or something. And they imagine, so we have an area of human activity where stuff happens that we think is relevant ethically, and we take the ethics and we sort of apply it to that place. Okay? First of all, applied ethics doesn't work that way because it always changes when you apply it. And secondly, AI doesn't work like that. It's not just one other area of human activity. It seems to me that it's a different beast altogether. So it's not an area ethics because AI is a universal technology. Computing has features of a universal technology to start with. Computers are universal machines that can compute anything that can be computed. And AI is also universal in the sense that it's, broadly speaking, about anything that you decide and predict. So, and everything that people do has to do with decisions and predictions. So it's just currently that certain things are more susceptible to AI, and there is not really such a thing as the border of this particular area of human activity where you can say, this is part of it, and the other stuff is not. Right? You see, it's quite different from medicine. Right? So what I'm doing here clearly is not medicine. Right? You can see that it's not part of it, but whether it's part of AI, I think is not so clear. So that's why AI ethics is pretty bad, because it really requires you to understand all of the technology, a lot of philosophy, and then all the areas where that is applied. So you have to be sort of a universal sage, right? That covers everything, which seems a pretty daunting task. So that's my explanation why I feel sort of stunned with the task. Here are some proposals how to handle it very quickly. One way to do it is to think of it as a matrix between two different kinds of things, namely places where AI is used, and then types of philosophical issues. So, for example, the issue of bias and privacy. There are issues that occur in different areas. So people can say, I'm an expert on privacy, right? I don't know. Carissa Velis works on privacy, right? You can say she does that. Now, where in different areas of use, or somebody else could say, I work on large language models vertically in my matrix, okay? So don't trust somebody who says, I work on the whole matrix. That's not going to happen, I think, in a human life. So one interesting question is, which cell should we work on? How should we work on that? Where does your expertise fit? Right? So maybe you can say, I know something about agency. Okay, so I can look at agency and moral agency in the horizontal sense. Okay, so there is a space for you there. Or you say, I'm an expert on something else, and I can look at it vertically. How to do this, I'm not going to talk about that today. My general tendency is to do it in a sort of low theory way. So I call that minimal ethics, because my experience with technology people is that they already do the ethics, they just don't call it ethics. They call it good engineering. Right? So, okay, we want to build bridges, but good bridges are the kind of bridges that don't collapse under normal weight. Okay, so that's already good engineering. It's not just an additional thing. It's part of the engineering itself. So they understand that, I think, quite well. And last but not least, another component of that is to see whether we can actually do good philosophy this way. So I'm suggesting that we can actually do almost all areas of philosophy through AI. So that's a different area that's called, I call that AI philosophy, and we're going to have a talk about this on Wednesday with Manuela Lenzen. So if you want to talk about that, then you have to come there. And I also want to mention that we just founded a journal, Guido Löhr and I, called Philosophy of AI, and we have founded a society, and we're having regular meetings, and we're going to have one in Amsterdam in a year from now, roughly. So thanks for that. There's plenty of work to be done. I hope you'll be on board. And for some samples of actual work, we're going to have the two speakers. Thanks. So now we need the new presentation. So I'm really happy that Colin made it over to Germany. I've been a fan of his work for a long time, but we never actually met in person. So Colin has been, and like many people in this field, has been coming to AI and computing through cognition, work on cognition, in his case, the philosophy of cognition and animal cognition specifically. And I think it's not accidental that there are several people who came to AI from animal cognition, right? Because you're looking at a broader notion of cognition outside the human case. So you say, what is cognition overall? And Colin has done lots of really influential work in that field. But as I said previously, he's also worked very early on machine morality. Has written a very well-known book with Wallach about that. And I'm really keen to see what he's working on right now.
So if the technology complies. So it has been said, this is not original to me, that, and thank you for the introduction, by the way, but the danger is not that AI will become so smart that it will take over the world. The trouble is that it's already taken over the world and it's so dumb. So we are stuck here with machines that don't quite work as seamlessly as we hope. Anyway, good. Thank you. So I'm actually going to try to focus a bit more on the non-ethical aspects of philosophy of AI. I think that some of the foundational issues that arise more generally in the philosophy of AI are going to have feedback into the ethical kinds of issues. But before launching into that, I want to also give some kudos to Vincent and his collaborator for starting this new journal that I believe you're going to start publishing next year. And the brief is to publish papers on philosophical topics from ethics to theoretical philosophy. So I'm going to try and steer towards the second arm of that. And of course, this comes at a moment when philosophy of AI itself is a growth industry. So those of you who are familiar with Google Ngrams will know that you can do a search for certain terms and it will show you the relative proportion of the entire corpus that contains those terms. So here we see from 1950 until 2022, actually, sort of relative percentage. Now, the number of words being produced every year keeps going up, so the actual number of words is growing faster than this chart. This is just as a proportion of the whole corpus. And you can see philosophy of AI continues to grow here. This just deals with different ways of capitalizing it in this particular graph. But if you look a little closer, you see that at least mentions of philosophy of AI pale in significance when compared to AI ethics as a phrase, right? This has been a huge growth industry since the mid-2010s. some earlier things, as already mentioned in Vincent's presentation, where some of us started thinking about how you would make machines themselves that could do the right thing, ethically or morally speaking. And I must say in English, we don't make a strong distinction between ethics and morality. I know that in German, Ethik is more theory and morality is more practice. We use those terms somewhat interchangeably in English. So a lot of words like machine ethics and moral machines and so on were being sort of coming up in the 2000s, but this is really being taken over by AI ethics, and a lot of people doing that work are not themselves professional philosophers. There's a huge amount of this literature which comes directly out of computer science. And if we burrow a little deeper, you might think, well, there are other things going on. We all know John Searle's Chinese room thought experiment. That turns out to have a very small signal compared to what's going on in AI ethics. But one thing that has been growing since the 1960s and it continues to grow and continues to accelerate even in the last 10 years is discussion of the Turing test. So the Turing test for intelligence, and of course the moment here is one in which people are thinking about not just AI as a particular tool for a particular task, but artificial general intelligence as something that really is universal in the sense that Vincent was talking about. So as philosophers, obviously many of us who work in this area come from a background of thinking about mind and cognition. AI has always been a test bed for those kinds of ideas. And some of the developments of recent years are extremely interesting from that point of view. With respect to the Turing test, though, it just won't die, and I'm afraid to say that I'm a little bit responsible because in that very first 2000 paper that Vincent mentioned, we proposed what we called a moral Turing test. Now, just this year, not this one, people have been trying to apply this moral Turing test to large language models, and it continues to be the case that people are sort of taken in by the capacities of these large language models. In one extreme, the famous case of Blake Lemoine, the engineer at Google, who claimed that the machines were already conscious, but lots of other more sober attempts to try to figure out just how well they do in a kind of conversational context. So this is an example of something from earlier this year, comparing large language models and human output, how it's assessed by human judges. I'm not going to dwell on this, but despite the headlines, I don't think the large language models have passed the Turing test. There are other people. There's a large literature in philosophy of AI, but still small compared to the rest of the literature on everything else. But people like Jack Copeland and Diane Proudfoot and Susan Sterrett really questioning what the Turing test actually is. And whether or not any of these more recent attempts to give it to machines really is the Turing test. That's a whole can of worms that I'm not going to get into. I really rather want to push a line against treating the Turing test as the kind of measure, the kind of thing that we should be looking at when we're trying to do serious philosophy of AI. But you see this kind of discussion. So here's a headline from a Nature article. ChatGPT broke the Turing test. The race is on for new ways to assess AI. And if you go to, for instance, OpenAI, the people behind GPT, ChatGPT as well, you'll see they're comparing their successive models with the most recent on the left against a number of standardized tests. So this is not a Turing test. This is trying to show how well these machines do against various kinds of tests that are given to humans in order to assess their capabilities. And there's really a couple of different approaches. These machines have shortcomings. I'm going to try to expose some of the shortcomings to you in a moment. But the idea of coming around those shortcomings really can take a couple of different tacks. So one tack is the standard sort of engineering approach, which is, okay, so a large language model itself cannot do so well on certain kinds of problems. So let's just add to it something that we know can solve those kinds of problems if primed in the right way. And so Google DeepMind, recently, who are the people behind AlphaGo and AlphaZero Chess and so on, recently, back in July, published this announcement that they had succeeded in creating a system which could do very high-level mathematical reasoning. But the way they do it, the architecture, I don't expect you to see that from the back, but the architecture involves using a symbolic engine, actually a system called Lean, which is just a straightforward symbolic theorem prover in interaction with a large language model. And as a piece of engineering, as something that then provides a useful tool, perhaps to mathematicians who want to figure out how to, run a lot of different possible ways of solving some problem that they don't know how to solve, this might, in fact, be quite useful. But as a model of human cognition, as a model of how our minds work, I do not have an instantiation of the Lean program running in my head. I don't know about any of you. This is not the way we do things, even if in our work we might interact with such a thing as an external object. So if we're thinking about this from the point of view of where are we in thinking about general intelligence and the kind of adaptive fluid intelligence that humans have, we might want to follow an approach which is represented here in this recent book by Cameron Buckner, who's a former PhD student of mine, where the subtitle of the book is What the History of Philosophy Can Teach Us About the Future of Artificial Intelligence. And I call this approach methodological empiricism because from a very long time there's been a discussion among people within the philosophy of AI, people like Jerry Fodor were involved in this discussion, about whether or not a kind of pure empiricist learning method that didn't start with any built-in knowledge, any built-in ideas, or any built-in concepts, could, in fact, acquire the kinds of capacities and concepts that we see in adult humans. Fodor very much in favor of a sort of innate rationalist built-in concept story. Buckner and others, I'm very sympathetic to this, is sort of saying, well, look, if we actually want to resolve this debate, what we have to do is be methodologically empiricist at least, because the armchair arguments that say a network can't do that kind of thing are bound to be undermined by people building networks to do that kind of thing. Of course, Fodor always argued that, yes, of course, a network could do that kind of thing, but then it would only be an implementation of the kind of symbolic architecture that he took to be central to cognition. But I think that that's really a question about whether or not that's the right strategy. Do you just build a virtual symbolic machine out of a network, or do you do it in some other way? Buckner's approach, and I fully agree with this, is to think more carefully about cognitive architectures that can give sort of, to a rough approximation, the appearance of being symbolic architectures, but actually aren't at core involving the kinds of innate structure or innate knowledge that Fodor thought. So a number of people have been critical of the idea that what we have now is on the way to artificial general intelligence. Melanie Mitchell wrote this in 2020 in her book, Artificial Intelligence, A Guide for Thinking Humans, in which she was looking only then at GPT-2, we're now at GPT-4, but she hasn't changed her essential view on this, saying that despite the enormous successes of those systems, they really are falling very short of the kind of artificial general intelligence, the kind of flexible adaptive intelligence that we humans have. She puts it provocatively by saying, it's like a monkey climbing a tree thinking it's on the way to the moon. David Chalmers gave a talk a year and a half ago now at the American Philosophical Association called Can Large Language Models Think, where he explicitly said she's a pessimist and I'm an optimist. And he gave a number of reasons in that talk for why he thought it was just a simple step from where we were then or even now to the kind of general intelligence. He mentioned three things. One is these systems don't have any actual perceptual systems. But he says, well, philosophy, particularly philosophy of religion, theology, tells us that thought without perception is a possibility, so maybe they think without that, so I say whatever. He says adding perceptual grounding is easy, and I think he's half right about this. So one of the tricks that allows these generative models like GPT to be able to generate images now with systems like DALL-E is that images and words are both actually core represented as vectors. They're in the same vector space. It's just a matter of transforming one kind of vector to another, and we've seen the enormous successes there. Although actually for perception, it's not quite so straightforward as that because they're dealing very much with static images. Another talk I have, I can show you all of the weird artifacts that happen in the images that are generated, but especially in moving images. They have real trouble with that. But he also said that one of the things that's clearly lacking from GPT is structure, but he thought abstracting structure from language is easy. I say not. And so an example that he actually gave in his talk was to say, could you generate a map of a public transport in a city simply from having a list of all the trips that people have taken using the public transport in that city? He said this will be easy for a large language model. So I tried it, all right, quite recently. Is it possible to do this? The large language model ChatGPT says yes, here's a bunch of things you have to do. It even gave me some pseudocode to do it. It gave me some sample data to run it on. And I noticed that in number 2, it says you have to ensure the data is clean and in a usable format. This might involve removing duplicates, correcting errors, standardizing the data format. So I went back to it and said, wouldn't you already have to know the network, what the network is, to be able to clean it up? And it goes, well, you're correct that this can be challenging, but here's a way to do that. And so it gave me a whole other bunch of interesting things and some more code. And in this code, it gave an example. In the description, it gave an example at point 3 of saying, well, for example, you might have 2 nodes that are labeled slightly different. Main Street spelled out or ST abbreviated. You've got to merge those into one. There's a way to do that. Here's the code to do it. Here's a data set. Hopefully already has that. I don't expect you to see that at the back again. So let's run this. And here's the graph you get. Well, it looks great, except notice that it didn't do what it said it was going to do. All right? So I say, but why are these separate nodes? It goes, seems the clustering step didn't properly merge, right? So it gives me a whole bunch more stuff, says, okay, I can clean this up. Here's the code to do it. We'll run it again. Right? And furthermore, it doubles down. It says, here's the updated visual representation of the public transport network. This time, Main Street, Main ST and Main Street are properly merged into a single node, right? So it's not even looking at what it generated here in any real sense. It's just BSing, as we say, all right? So provisional conclusions here are that ChatGPT, and I think this generalizes to other large language models, do not know what they're doing. Their behavior is not driven by any of the structures they describe, and they lack any kind of metacognitive monitoring and control of their own errors or their own error correction, right? It's just ballistic, given some stimulus, out comes some response. There's no there underneath this that's corresponding to the things that it's saying. And this is a real problem. I said, I'm not going to say much about AI ethics, but I think this is a real problem when we think about implementing control structures for ethics as well, and I think Björn is going to say some things about that in his part. So in particular, large language models lack an important signature of adaptive cognition. So Vincent mentioned that I've also worked quite a bit in animal cognition. A recent paper that I had with a couple of biologists and another philosopher, Rachel Brown, where we look at what's missing in standard animal testing and also in AI testing, and what needs to be done better. And what's missing is attention to not just whether an organism can do some specified task, but the particular signature of ways in which it does that task, might fail in that task, might be able to correct its own errors in that task, and so on. Animals are, for want of a better term, kind of epistemic agents, right? They seek information, they do things with that information. When things go wrong, they recalibrate, right? They have this kind of internal drive to do this kind of thing and a certain degree of self-monitoring, depending, of course, on the animal. So the idea here is that we want a much more detailed, process-oriented understanding of what's going on in these systems, and people are, in fact, working on this. But to many people, this sounds like shifting the goalposts. So if you look in the AI literature, you'll see people complaining, well, first they said we couldn't play chess at the top level, but now we can. Then they said Go, now we can. Then they said language, now we can. And people keep shifting the goalpost. And I fully own that. Yes, we are shifting the goalpost. Science is always shifting the goalposts, right? When you get something that works for a range of purposes, you find out that it also doesn't work for other purposes, and so you have to adjust. You have to come up with a better theory in the physics case here, better systems in the engineering case here. Nevertheless, it's important to have targets. We learn from trying to hit them, and we develop better targets when hitting them proves less satisfying than hoped. So I'm going to end here just with the last two paragraphs of Turing's 1950 paper. I'm not going to read the whole thing, but he says, look, maybe playing chess would be best way to go about trying to get something that would satisfy us. Maybe training something like a child to understand and speak English. To which I want to say that large language models are not trained in any way like the child. We actually don't know what their learning profile is like, because all we're presented with is the final product. We don't see what kinds of errors it makes. The kind of correction they get is also not the kind of correction which leads to later self-correction, whereas the kind of correction we give to kids is, oh, there's a rule here, or though there's a structure here that you should pay attention to if you're doing your graph model or your algebra or whatever it is, right? So I don't think this approach has really been properly tried. He says, I don't know what the right answer is. I think both approaches should be tried. There's actually many more than both approaches. And he ends by saying, we can only see a short distance ahead, but we can see plenty there that needs to be done. And I would say the same is true. We can only see a short distance ahead, but we can see plenty there that needs to be done. And we just want to be mindful, though, and I think this is the problem with chasing after particular benchmarks or particular measures, of what's come to be known as Goodhart's law, which he didn't actually state in exactly this form. And he stated it in the context of economics, like when pursuing a particular fiscal goal undermines the purpose of using that measure. I think very much we're seeing this with current AI. So people can move the delta, as they say. They can get slightly better performance on some standardized test, but they're really not getting at whether the underlying processes have the right kind of adaptive, flexible cognition that we think is available to us. So that's the end of my remarks for now, and I look forward to the further discussion. Thank you.
Okay, hey, good. Let's see if the clicker also works. Yes. Okay, so a lot of people worry that if AI systems become super intelligent, we're gonna lose control over them, and they might do things we don't want them to do, basically. This is what's called the control problem. I want to state firstly that I think the control problem is already present in the sense that as soon as we have fast-paced decision-making, faster than we can interact with, that's impactful, we already have a control problem. One good example of that might be AI-based infrastructure, which of course is not present yet, but might be more in the future. So if suppose autonomous vehicles take over, we might need an AI that controls this system. Decisions are going to happen so fast, I mean, that's quantity of data that we're not going to be able to have sort of meaningful human control. Why do we need control? Well, sometimes human decision-making matters, right? So we believe that democracy, for example, is important. We think that certain types of decisions should be made by humans intrinsically, right? We might also want to avoid being dominated by AI systems. Or we might want to ensure that AI systems are value-aligned. And this is what I'm going to focus on here. So the worry here is basically that most AI systems are optimized goal satisfiers, but a goal that might seem good might end up sometimes in suboptimal outcomes, or even catastrophic outcomes. And so we might need to retain control over important decisions or over super intelligent systems to avoid this. Let me give you an example. So here is a trivial issue. We want to have an AI play Tetris. And somebody actually did it. They tried to make an AI play Tetris. I guess you're all familiar with the game, right? So unlike chess and Go, Tetris doesn't have a winning condition. So we can't just tell the AI, you do what needs to be done optimally to win the game. So we need to give it a goal. The goal was given, do not lose. Now, how do you think the AI solved this problem? Anyone? Any guess here? Vincent, how do you think the AI solved the problem?
Prevent the others from playing?
Yeah, sort of like, it paused the game. And I think this is an excellent illustration of, if I told you guys, I want you to play Tetris, I don't want you to lose, you would understand the contextual sort of background of this. It would not be actually playing the game if I pause. Now, this is a trivial situation, but suppose we're running in a healthcare facility. We might sort of give the goal, avoid deaths. Now, the avoid deaths, for a human, we understand what that means. But for an AI, it's a logical system. That might actually mean stop measuring patients when they're close to dying. Or do not admit patients that are really sort of not going to do very well. And a healthcare facility like that, we might say, oh, yes, stop running it. But we might face an important on-off trade-off in the sense that people are doing really well in the hospital, those who actually get care. And suddenly, so if we shut it off, we have this weird on-off trade-off. And this is not easily avoidable in sort of machine learning because it's sometimes difficult to understand what the logical implication of a goal when we avoid context. Okay, so there's a potential simple solution here. Maybe we should sort of give AI the overarching goal of always keeping humans in control. That might sound really simple. There are some obvious problems. We don't know what control is, right? We don't know what meaningful control actually entails. There's some literature in the philosophy where control is a common concept, and it's often fairly badly defined, right? And it might also make the system less efficient. So another option is that we can sort of avoid having control if we can ensure that the system is value aligned. So I think an illustrative example of this solution is to think of if God exists and God has all these properties we normally assign to God, God would be good, right? So there's no problem that we can't control God, and we really can't control God because God is all-powerful, and that's not an issue because God is all good. So we can assure that the AI actually doing good stuff, we might not need to control it. I'm going to argue that this solution doesn't work. I'm going to start by looking at the solution by someone named Stuart Russell. If you're not familiar with this name, because he's not a philosopher, let me tell you that this is one of the biggest names in the field of AI. And I think these guys will agree when I say that. So I haven't just picked that stupid guy that I'm going to show you that his proposal doesn't work. Based on that, I'm going to re-diagnose the problem, and then I'm going to discuss some alternatives. And I'm looking here at Vincent. I see we're pressed for time, so I'm going to speed up as fast as I can. And I'm basically going to argue that we cannot do value alignment without control if you want to solve the control problem. And that means to some degree that we're facing a conceptual issue. We need to sort of define what meaningful human control is. So quickly now, what is Russell's proposals? Well, he realizes, as we all do, that we're basically facing a problem of uncertainty. We have at least empirical and normative uncertainty. I mean, we arguably also have modal uncertainty if we believe that's a distinct category. Russell also wants to avoid actual logical discussion. After which he suddenly says, and now philosophers are going to laugh, goal of AI satisfy human preferences. I don't know how that is avoiding an actual logical discussion from a philosophical perspective, but in fairness to Russell, he doesn't want to tell you what you think is valuable. But of course, he's saying what's valuable, and he says that preferences are valuable. So how can this be achieved? How can the AI know humans' preferences? And here comes the other part of his solution. So the solution depends on AI recognizing that it only has uncertain information about our preferences. And hence, it has to engage in experimentation to test preferences. As a consequence now, and Russell says it quite clearly, the AI is allowed to alter your preferences. So let me give you an example. Suppose the AI is present at this conference. It asks people if you want coffee. In fairness to Russell, after some people say yes and accept the coffee, the AI can sort of say, okay, now I'm going to increase the likelihood that you want coffee. Now, in fairness to Russell, I think he's focused on revealed rather than stated preferences, but I'm being kind to him. I'm including here another data point. it's important here that the probability is, of course, not going from 0 to 100 because there is this uncertainty. Now, there are various obvious problems with this, and I mean, there's a huge literature on problems with preference utilitarianism. And I don't want to go into all of that, but I'm going to discuss some of it. So there's a problem related to sort of revealed versus stated preferences. There is a problem here related to future generations, and there is harmful preference manipulation, which is what I will focus on. I'm going to speed up now, Vincent, so that you don't have to worry about the time. So we know that stated and revealed preferences are in conflict. I'm not going to give you an example of that. It's kind of obvious. It's not clear that they actually properly codify our actual preference. There may be informational gaps. And revealed, as we will see, preference can sometimes be problematic. Here is where the uncertainty criterion in his solution might actually be to a benefit, because if you keep being uncertain, if you think of the coffee, the coffee is compatible with all kinds of other options. Maybe you were just tired, you don't really like coffee, but you were so tired so you had the coffee. Maybe you were thirsty and that was the only option I was offering you, so you drank the coffee. There's a whole plethora of hypotheses compatible with that, and as long as it retains uncertainty, there is some potential way of solving these type of problems. So the data points are basically predictive, not determinative. Another issue is sort of future generations. How much weight should we give to them, current versus future and current? But the basic problem here, we cannot run experiments on the future generations because they do not exist. So the whole model of how to achieve these data points for the AI doesn't really work because they are not accessible. And we know, based on sort of a very broad literature on moral change, that future generations are likely to change in their moral preference, right, as they have done through history. Again, we could potentially see how the uncertainty criterion can solve this because it remains uncertain about future generations, so it remains open to what they might do. Now, here's what I think is a more problematic issue for Russell's solution. Experimentation can lead to what I call undesirable local optimas. So let me give you an example. Instead of giving you guys coffee, I'm going to give you guys heroin. Afterwards, I'm going to ask if you want more. And this is a very addictive drug, so very likely at least some of you will want more. But it is, however, clear that you didn't want to be in that situation to begin with. Now, since the goal here is preference satisfaction, and altering preferences are allowed, this is not a far-fetched scenario. Because the AI is a logic-based system. It's going to find the simplest solution. The simplest solution here is finding a situation when preference satisfaction is easy. Making you drug addicted is an easy way of ensuring that that's going to happen. Now, there's no simple solution to this problem because it basically depends on the solution as such. We go from uncertainty to experimentation, and experimentation requires manipulation. So all that is needed here is a state of affairs that we don't want to be in, but once we're in that state, we want to remain in that state. And then you have what I call a suboptimal localized preference, or a loop. Okay, so I think this is enough to sort of react to Russell's solution. This doesn't work. It's implausible in this sense. I think we should all agree with that. And we still need some sort of human control, it seems, to avoid these undesirable local optimal loops. So what's the issue here? Well, I don't think, like Russell thinks, that we can avoid a more detailed axiological discussion. And clearly, some revealed preferences are bad. And we want the AI to avoid creating undesirable local optimal loops, but they are difficult to define. Now, earlier I said that we can worry about suboptimal outcomes, we can worry about catastrophic outcomes. I think this example shows that we should be more concerned potentially with catastrophic outcomes. Now, when I say catastrophic, often when we say catastrophic, we mean something that applies to a large quantity of people, but something can also be catastrophic for an individual. So the question that we're addressing right now is not necessarily what normative theory that is correct, nor is it about non-normativity to apply under a certainty, but what kind of goal we should give the AI to avoid sort of these catastrophic outcomes. And for the present purpose, if those goals can be avoided, can avoid the need for human control, can we sort of define ethical conditions that solve the control problem without having control as part of those ethical conditions. Okay, how am I with time? It's okay. Okay, he wants me to speed up. So let me just quickly point out that this seems to sort of generalize the sort of utilitarianistic theories. So you can think of, for example, Nozick's experience machine to see how it extends to classical utilitarianism. And you can then realize that they're probably going to generalize to other forms of utility as well. So now I'm moving really quickly over this slide. More interesting is perhaps the idea then that the problem might be value monism. It might be that one value is more sensitive to formal corruption, and we might solve this if we add a value, going back to the simplest, we might solve this if we have a special value that's about satisfying, avoiding these undesirable local optimal loops. One proposal for that is autonomy, right? If you have human autonomy, if you're fully autonomous, you're not fully autonomous if you're addicted to drugs, right? So if you're fully autonomous, you wouldn't you don't want to be there, and then the AI would help you out of that situation. Problem, of course, is that standard use of autonomy implies some form of control. And even if we go to use of autonomy that isn't control-based, we have an information gathering problem. In Russell's situation, we had the problem of gathering information through experimentation, because experimentation requires manipulation, and manipulation was the root of the problem. But even if we can gather information with actual experimentation, it doesn't seem to be free from problems either. So for example, we can consider looking back to the past. But if you look back to the past of an individual and see if the individual acts in sort of an authentic way in relation to their past historical data points, that's going to be biased towards an inability for the individual to change their preferences. So even with those type of options, we seem to have a problem, right? So that would be once a Yankee, always a Yankee, right? Because that would match with the historical data points. So even if we try to sort of gather information without experimentation, we still have a problem. So value maintained through autonomy, it's arguably a little bit problematic as well. So what about capabilities then? So the capability approach is the idea that we want to give people capabilities that sort of matters for living a good life, basically. And that might be a good solution also for the problem between sort of current and future generations, because we just want to ensure that future generations have these good capabilities. And basically, if we find the right capabilities and we ensure that the AI focuses on that, future generations and current generations can freely shape their lives. So what kind of abilities do we need to safeguard, to sort of avoid the control problem, to avoid catastrophe, and how do we define them formally? How do we ensure that the selection of capabilities is adapted for a potential future generation beyond mankind as we know it? Let's look at some example here. So one example is, and the most famous one is Nussbaum's list of capabilities. Now here's Nussbaum's 10th capability: control over one's environment. So you see, control just comes back at you, whatever option you pick. So basically, we cannot solve the control problem with this solution either without defining control and assuming human control. You might want to think, oh, maybe we can get around that. Maybe we can somehow define control otherwise, but that you can easily see how that goes back to the previous problems I have discussed. We don't need to go into this. Okay, another idea might be to not focus on the individual, but the human collective. And I took this idea from Toby Ord, one of the long-termists, and he basically says that humanity's long-term potential is sort of defined in terms of the set of all possible futures that remain open to us. So now it's a very, very minimalistic requirement, right? This doesn't seem to work either. So increasing possible futures is not necessarily good, because, for example, increase the number of viruses in the world increases the number of possible future. I would rather prefer not having COVID in the future, but that would reduce my future possibilities open for me. Quantitatively also, more possibilities is not necessarily better than fewer possibilities. So imagine this is the choices we can set, how we can set the temperature of the room. Now the first option, of course, has more options for us, while the second option has fewer options, but clearly, for most people in here, I think you would prefer picking a temperature from the second option. Okay, are there other alternatives? Obviously, we haven't discussed the ontology, rights-based approaches, Kantianism, and so forth. But I'm looking at Vincent again, and he wants me to quit right now, and I actually predicted that, being a good AI. So I'm going to sort of, as the auditions say, I'm going to leave this as an exercise for the audience. I'm going to sum up really quickly now, Vincent, so that we can go back to Q&A. I rejected several attempts to solve the control problem of alignment for control, and that's fairly quickly, since I feel like Vincent's pressure here. I reacted Russell's solution. I hinted that it's easy to react utilitarianism and other forms of consequentialism. I reacted sort of solving this by sort of thinking of how we can also protect autonomy, capability approaches, focus on future possibilities, and it seems that it's impossible to get around the control problem through value alignment without having some sort of notion of control in the mixture, given at least the examples I have considered. And I think you can easily see how that would generalize to other alternatives as well, which implies general implausibility. Hence, we cannot solve the control problem without meaningful human control. Thank you.
Good. So, end of us talking at you. Now a chance for you to ask questions and comments and complaints. We have 15, 20 minutes to do that. So you're welcome to talk. I think if you want people who hear this online to listen, then we probably need the microphone. Otherwise, you can just sort of speak up. So hands. Any hands? I can see some hands. Hands from people less than 40 years old, yes. Use the mic.
Yes. This is a question for the AI experts on the stage, and especially for the second speaker. I think you pointed out the problem of let's say, a missing capacity of reflexivity of AI, and I just had the association that with human reflexivity, we know that we often get the reflexivity or the capacity of it by learning through the example of other reflective entities, let's say. And I was wondering, just a very layman's question, in how far are AI models learning from other AI models, and would that be a possible route to a certain kind of reflexivity to, in the way, learn what they are doing?
Yeah, good, thanks. So I think you're right that we learn from models of other people who are more reflexive than our earlier selves. We also do it both by observing their behavior and also being told to slow down, to think before we speak, these kinds of sort of control of our own behavior, pieces of advice that we get. Now, in terms of machines learning from each other, this is actually a big part of the Google DeepMind project with the Alpha Zero type models, where one chess playing machine will play against another, or one Go playing machine against another, but they're not learning anything reflexive from that. They're simply getting reinforced or not based on whether or not the move that they chose at a particular moment in a game eventually leads to a victory or a loss, right? And so that ultimate outcome is then trickled back through the entire sequence of moves, kind of reweighting all of the decisions that were made earlier. But there's no control mechanism there that's being learned to say, right now this seems like the best move, but maybe if you thought a little harder, you would see there's some, right? Nothing like that is a consequence of that. Also, many of you will know that ChatGPT and these other public large language models, the ones you can actually chat with, involve reinforcement learning. But again, it's not an outcome in a game that's doing the reinforcement. It's people saying, yes, that's a good response, or no, that's not a good response, that's being used to reweight the machine's response. But again, it will be, the next time it's in a similar situation, it will be completely ballistic and just spit out whatever fits the profile given the way in which it generates these responses. There's no control being provided, and the kind of feedback that's coming from people is not the kind of feedback that goes on, in Turing's imagined, have the child learn, have the machine learn in the way that the child would learn, right? Because children are not just being told, yes, that's wrong, or yes, that's fine. They're being told strategies to deploy for making better decisions next time. And a large language model can be told strategies. It will repeat those strategies. It'll tell you what the thing is to do. But then, as the kind of example I showed, it cannot actually apply those strategies, right? It's sort of entirely dependent just on sort of this kind of very shallow kind of reinforcement of its behavior. So I think that's a huge gap, and how we do that, how you can build it into machines, these are very big and difficult questions. Some people within the industry and academia think that we don't need to do it because machines will just do it their own way. I'm more of the orientation to think that, you know, however many hundred thousands of years, millions of years of evolution are behind the construction of the kinds of capacities we have, shouldn't be ignored. There's real reasons to do things in the way that we do it, rather than in this sort of very shallow kind of direct reinforcement method.
Thanks, Vincent. I wanted to ask you about what you said about AI philosophy and the intriguing idea that almost any area of philosophy could be done through AI. Now, for the people working in AI, that might be great news. So many things we can explore. But how would you respond to the skeptics saying, well, if that's true, maybe there's nothing distinctive about AI, and we should rather stick to the traditional territory?
The idea is not that the AI does the philosophy. The idea is that we do the philosophy through the AI. But how that works, we'll find out on Wednesday. It's a cliffhanger.
Question to the third speaker. There are people who maintain that alignment isn't a problem but a myth. I'm not with them. I'm with you and say alignment is a real problem. I'm also with you when you say that control must be part of any solution to the alignment problem. But I'm somewhat unsatisfied with the gist of your critical argument against Russell, because, I mean, that may be a bit unfair to say, but the gist seems to be there's a control problem because there's a control problem. That's the last line. And what I want to know, could you say once again, what exactly do you find problematic with the notion of control? That seems to be the sore spot. And the only thing I remember from your talk is you said the concept is somewhat vague. Is that the only argument against, analyzing and amplifying and exploring the notion of control?
I'm not against the idea that we should. I think we should explore the notion of control. I just think that the notion of control is not yet sufficiently explored so that we can sort of formalize it in a way that we can tell an AI this is what you should satisfy. There are interesting versions of solving the control problem that views it as the slimmer problem, that views it as sort of what's called the shutdown problem. Because some people worry that sort of like a super intelligent AI is going to resist being shut down. And so the idea is that you train it in a training setting so that it always has a sort of option of shutting down. And that might work, but I haven't looked into that clearly. But that would be a slimmer version. But with the issue of control, I just think it's sort of underdeveloped. I'm not saying that we can't do that. The argument here is that if you want to solve the control problem by going to value alignment, you're not going to solve it unless you already have solved the control problem. So like value alignment is not a solution. That's all I'm trying to say here. Yeah.
Yes, thank you very much, both of you. The question can also be taken by both of you. The key notion that you propose is meaningful human control. Yeah? Meaningful human control is something that you have to presuppose. Now the question is, to which degree do you think that AI system can develop meaningful human control? They developed as an emergent property communication abilities as the LLMs have them. Of course, they are emerging on the base in a way that is simulating communication. So why should the systems not be able to simulate meaningful human control in the future, so that what you say what is lacking to solve the control problem will be not fully taken over by AI system, but will be approached stepwise in the same way as the LLMs stepwise get competent in communicative abilities?
I think it goes partly to Colin's talk, and it is that LLMs are unable to reason, I would say. And I think complementing what Colin has already said, I think an illustrative example of this, although this research was probably done on GPT-3, is so-called Caesar ciphers. I'm sure you're familiar with this. So a Caesar cipher is basically a very simple cipher where you take any letter every letter in a word, and you just you interchange it for another letter, n plus something. So it's like A, if you add n plus 1, you have A becomes B, B becomes C, and so forth. If you ask at least GPT-3, give me a Caesar cipher this sentence, it normal success for a random given n plus was around 1 or 2%. Like any human can do this. I mean, ask a kid, if you explain this to them and they understand the alphabet, they can do this. It managed on an 80% level on 2 types of Caesar ciphers. I don't remember the numbers, but the reason was because those type of ciphers are common in the corpus that it's been trained on. And I think it's illustrative, and I hope Colin would agree, with the fact that LLMs are not really reasoning. They're just applying a probabilistic model based on the training data. So I don't see how they're going to, and some people think that you can solve the control problem for LLMs because now suddenly we can talk to them. But talking is not the issue. Reasoning is the issue, right? Do you want to add something?
Yeah, I mean, I would say, though, that there are efforts underway to try to use some architecture that involves LLMs to engage in a kind of reasoning process. So one way is to actually train LLMs to look at the output of other LLMs and select among them and sort of slow down so not just output the first thing that one LLM model. Now, I think there's all kinds of reasons to think that this may not work, but I wouldn't bet strong money either way, because that's just a very sketchy description of the architecture. Maybe some more complicated thing would do it. But the key point for me always, and I think this comes back to control that we can trust, is that you have a system that, even if it's operating at a speed and in locations where direct human oversight is not possible, nevertheless you have sufficient understanding of the way in which it can be regulated internally to be confident to let it operate in those circumstances. And we're a long way from that. I think that many people are very gullibly sort of using LLMs to do things that they have no business doing. I don't think the problem is unsolvable. It's just not going to be solved by the architectures we currently have.
I mean, I could add quickly that I think what we want is provable control, right? And that is not something that we can achieve with LLMs. Okay.
In your talk, Mr. Müller, you said that engineers don't call it ethics, but just good engineering. And sorry. So you said engineers don't call it ethics, but good engineering. So my question would be, like, how should we continue about ethics in like computer science in general, maybe even? Like, should we enable computer scientists to be more capable of ethics and to be more aware that they actually do ethics and that it is important that they will continue to do so? Or should we actively involve philosophers to get in contact with computer scientists to support them with their expertise? Or should we introduce like more transactional experts that know both worlds and then can like combine the knowledge and do the ethics for them?
Yeah, so what did I mean by this idea of good engineering? So the background to that is a story. So I was a chair in the Technical University of Eindhoven a couple of years ago, and they introduced a master in AI. And they said, "Oh, we need some ethics or whatever that is in the course, and you're the professor for that. So can you do that stuff? And what would you do?" And initially they thought of this as we're doing the work, and then you do this other stuff that needs to be covered. And obviously I didn't want that role. So I discussed with them what it is that they're doing and suggested that both of the things that you mentioned are true. A, you're already doing ethics because you're already considering what counts as a good solution, right? Yes, building the bridge but poisoning all the fish isn't such a good solution. So, and that's not an engineering remark, right? And you're already telling your students, this is a good solution, this is not so good, this takes too many resources or things like that. There is a component in which you're already doing ethics, and there is, of course, a component where I can help you do ethics because I have a bit of theoretical background to do this, and teaching that to the students would help. The end of the story was that the whole AI master was put under the label of good engineering. We want to train good engineers. So contrary to what they thought, I was not going to be the latched-on thing that nobody really cares about. It turns out that they also wanted to say, yes, 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 and in my class, which is statistics 2 or something, I am going to teach this thing which is really important for them to become good engineers. Right? Because, I don't know, you can prove that the likelihood of so-and-so event is... So really, this was an important sort of thought process for me. I thought, okay, they really want to do good engineering. And so they really want to have the ethics in their actual work, as opposed to being the thing that you might discuss over a beer after the actual work is finished. Okay? So that's why I thought actually maybe ethics should be adjusting to that situation a little bit and be a bit more minimal. So if we hit them straight away with a categorical imperative, they might not be so thrilled, right? But if they understand why that's relevant to what they're doing, then I think that might work. But that's a longer story, obviously, than the 3 sentences I had there. Thanks.
Thanks a lot for the very interesting presentations. So I take from what you have said that we are not very good in giving any solution of the control problem. So we do have a major problem. But maybe, and this is a question for both of you, we could at least avoid letting it get worse and worse by advocating the skeptical stance like Colin did in his talk, because I mean, I am really scared about how many people trust blindly in the outputs of machines where we as computer scientists and mathematics can prove it's not reliable. We know it. And the control problem is getting so much worse if people start to trust in the machines in the sense they trust to the machines right now. And so I think the first step for the ethic of AI is a kind of enlightenment and make people aware about the mistakes before they can do something awful.
I agree fully, and I think the problem mis and disinformation really illustrates the complexity of these issues, right? I mean, solving that is this philosophical question, it's a social science question, it's a computer science question, it revolves around all kinds of issues, I think. So, but it's not easy, especially not in the sort of current political climate. And I mean, Colin is in the US, so he can tell you more about that.
I will not talk about US politics, but yes, so I completely agree. One other project that I've had over the last couple of years is talking about wisdom in the machine age. And we characterize wisdom as involving a metacognitive component on the part of users of machines as well, understanding the limits of those machines. And the question is, how do we get them to understand that? And I think you can tell people they're limited, but that means nothing. You've got to actually give them some sort of direct experience with those limits. So, for example, in the case of self-driving cars, maybe it should be required, just like for pilots, that they go into a simulator and then the simulator puts them in situations that normally they would not encounter on the road for themselves, right? And they figure out that this thing actually is going to behave quite unpredictably or badly in those situations, and this will make them more careful maybe in deciding when to use that or not. So this kind of movement, of course, is extremely unpopular, you know, with the manufacturers of such vehicles, because they don't want to tell their users that they require special training to use it. But not just there. I think in all sorts of areas, I try in my classes to tell students right from the beginning about GPT and the sort of mediocre work that it will do for them. Many of them, they're satisfied with this mediocre work, but sort of getting them to understand its real limitations, and giving them direct experience with that real limitation, I think is an essential part of our role as professional skeptics, to get other people to take that skeptical attitude. Yeah.
Good. I think professional skeptics is a very nice closing statement for this session. So please join me in thanking our speakers for this afternoon. And I thank you for the questions and the lively discussion. So see you around.